Hello everyone and welcome back to Unit 11.5 Part 2. In this lesson we're going to be looking at how we can write a ratio as a unit ratio, okay, or in unitary form. It depends how the question states it. So if we look at the key point 6, it says you can compare ratios by writing them as unit ratios. In a unit ratio, one of the numbers is 1, okay? So if you're ever asked to simplify it into unitary form or write it in as a unit ratio, something like that, you know that one of your numbers is always going to be 1. Okay? And the number that will be 1 will be the smallest number that's in your ratio. That'll make more sense as I go through these examples. So let me just get the visualizer up and I'll go through the example, the two questions that are on the screen. Okay, so the question has asked you to write this ratio as a unit ratio, okay? So as we know from our key point, that means one of the numbers in the ratio is going to be 1. You look at the ratio you've been given, so that's 5 to 3, this is part A. 5 to 3, which is the smallest number in that ratio? Well, it's 3. How do I get 3 to 1? I divide by 3. That gives me 1. Now I know when I'm simplifying ratios, or I've been asked to write it as a unit ratio, anything like that, it's simplifying. To keep it equivalent, we've got to do the same thing to both sides, otherwise we're changing the ratio. So as I've divided this side by 3, I must divide this side by 3 too. Okay, so now I need to work out what 5 divided by 3 is. I know it doesn't divide exactly, so I'm going to use the bus stop method to work out exactly what my answer would be. So I'm doing 5 divided by 3. 3 goes into 5 once. This is now going to become a decimal because we've got to the end of our number that we're dividing, with 2 remaining. So that becomes 20. 3 goes into 26 times, with 2 remaining. That becomes 20. 3 goes into 26 times, with 2 remaining, so you know this is going to carry on, and actually that's going to become, it's going to be recurring. So I'm going to round my number to 2 decimal places, so 1.66 recurring to 2 decimal places is 1.67, okay, because we'd had a 6 next, and that 6 would round this 6 up to 7. So I'm going to call that 1.67, okay, and that's my final answer. I have now written 5 to 3 as a unit ratio, and as a unit ratio it's 1.67 to 1. Okay, part B. We have got 2 to 7. First question I asked myself, which is the smallest number in that ratio? It's 2. That means I'm going to divide both parts of my ratio by 2 in order to get this to be a unit ratio. So divide by 2, divide by 2. Okay? 2 divided by 2 is 1. That shows this is definitely a unit ratio. 7 divided by 2 is going to be 3.5 because it's half of 7 is 3.5. And that's my answer as a unit ratio or in unitary form. Okay? So please pause the video and have a go. It's asked you to write each of these in the form m to 1. Give each answer to a maximum of 2 decimal places, okay? So be careful there because that's different to what I've just told you in the example before, because it didn't specify which one you wanted as your unit ratio. I picked the smallest number, but this time it has told you that the second number has to be 1. So it doesn't matter which one's bigger or smaller, the second number must be 1 in your answer here, okay? So whichever one is second in your ratio is the one that you're going to be dividing to get to 1. So please pause the video and play when you're ready to go through the solution. Okay, so I'm writing the ratios in the form m to 1 as a unit ratio, but the second number specifically must be 1. So in part A, I've been given the ratio 2 to 5. This number has to be 1. The 5 needs to be 1 because it's the second number in my ratio. So I'm dividing both sides by 5. Okay? 5 divided by 5 gives me 1. And then 2 divided by 5, well, I can't do 2 divided, it won't be a whole number, so I'm going to have to use my bus stop. I have 2, and I'm dividing it by 5. Okay? 5 doesn't go into 2, so here I put 0. I need to put the decimal in because I've got to the end of my number, and carry my 2 over, and it becomes 20. 5 goes into 20 4 times, so my answer there is 0.4, 0.4. Okay? And that's it, you're done. Part B. 7 to 4 is my ratio. Remember, I'm doing it m to 1, therefore my 4 is the one that's going to be simplified down to 1. To get 4 to 1, I divide by 4, therefore I need to divide my 7 by 4 to keep my ratio equivalent. 4 divided by 4 is 1. 7 divided by 4, well, I don't know, it doesn't go exactly, so I'm going to have to use my bus stop. And remember, it said a maximum of 2 decimal places, okay? So you don't need to go on further than 2 decimal places. So I'm doing 7, and I'm dividing that by 4. 4 goes into 7 once, with 3 remaining. 4 goes into 30, 7 times, with 2 remaining. That becomes 20. 20 divided by 4 is 5. So your answer there is 1.75. Okay, part C. We're going to have m to 1, and we've got 16 to 9. Therefore, the 9 is the one that's going to be 1 in our final ratio. So we're dividing both sides by 9. 9 divided by 9 is 1. I don't know 16 divided by 9, so I'm going to need to use my bus stop method. So 9 doesn't go into 1, so I just move that on and I'll make that 16. 9 goes into 16 once. I need my decimal because I've got to the end of my number, and then there's 7 remaining. Okay, that's 7 becomes 70. And then I need to say how many 9s go into 70. That's going to be 7, because it goes to 63 with 7 remaining. Okay, that becomes 70 again. What's going to happen here? 9 goes into 70 7 times with 7 remaining. That becomes 70. So we know it's going to go on and it is recurring. Okay. The question says give each answer to a maximum of 2 decimal places. This 7 is going to round this 7 up to 8, so that is going to be 1.78 to 2 decimal places. Okay. So that's your answer, 1.78 to 1. Part D, we've got 5 to 36. Remember, it's m to 1, so it's a 36 that's going to be 1, so it's going to be a bit of a strange one. So we need to divide both sides by 36. 36 goes into 36 once, and now we need to work out what is 5 divided by 36, remembering we only need it to 2 decimal places. Okay? So 36 doesn't go into 5, so that's a 0. Put our decimals in because we've got to the end of the number, and we carry the 5, and it becomes 50. 36 goes into 50 once, with 14 remaining. That 14 becomes 140. Okay? 36 goes into 140 3 times, with 32 remaining. So we have 32 remaining there, so that becomes 320. Then we have to work out how many times 320, 36 goes into 320. That's going to be 8 times, with some remaining. Let's see how many remaining. So we've got, it would be with 32 remaining again, okay? And then that's going to just carry on, and it would be the 8 that would be recurring, okay? It only wants it to 2 decimal places, so I look at the 8, it's going to round the 3 up to 4, so to two decimal places, it's going to be 0.14. Okay, so 0.14 to 1 is your ratio. Okay, actually, I think once you know what a unit ratio is, the hardest part is the division. They don't always give you them as difficult as this. Okay, and sometimes you maybe have a calculator if it was a question like this. Okay, the next one, we've got 9 to 42. Remember, it's m to 1. So this number needs to be 1 in our final answer. Therefore, we're going to divide both sides by 42. So that side would become 1, and this side we need to work out what is 9 divided by 42. Okay? 42 doesn't go into 9, so that's 0. We've got to the end of the number, so we need to put our decimal in. Carry our 9, and it becomes 90. 42 goes into 90 twice, because that would be 84. With 6 remaining, that makes 60. It goes into 60, let's just extend that, goes into 60 once, with 18 remaining. That becomes 180. It goes into 180 4 times, with 12 remaining. Okay, that would become 120, and so on, but we don't need to carry on because we only need our answer to 2 decimal places. Okay, so I look at the 4 that's next to the second decimal place. It's 4 or less, therefore it's going to keep the 1 the same, and my answer is 0.21. So it would be 0.21 to 1. Last one, F. We have got 11 to 56, and we're doing it m to 1, remember, so this number is going to be the one that's 1 in our final answer. 56 divided by 56 is how we get to 1. Therefore, we need to do 11 divided by 56. So let's do that. We have 11 here, and 56 here. 56 doesn't go into 11 at all, so that's going to be a 0. We've got to the end of the number, so we need to put a decimal. We carry the 11 and put the 0 on the end. 56 goes into 110 once, with 54 remaining, so that's going to become 540. 56 goes into 549 times, with 36 remaining. That becomes 360. 56 goes into 360 6 times, and it doesn't matter how many is remaining now because we're rounded to 2 decimal places. So that carries on, that would carry on, but we're only looking to 2 decimal places. So we look at the number, the third decimal place along, it's 6, so it's more than 5, so it's going to round my 9 up, and it's going to round my 9 up to 10, so actually it becomes 0.20. Okay, 0.20. We don't need that 0 on the end there. It hasn't said we have to give our answer to exactly 2 decimal places. It's just said a maximum of 2 decimal places. So it's up to you. Either would be right, 0.2 or 0.20, but 0.2 is fine because it hasn't said it has to be 2 decimal places. Okay? And that's the end of that question. So well done if you got those. If you didn't, if you struggled, check what you struggled with. If you're okay with understanding the method that you have to use, so you understand how you get it to the unitary ratio or to a unit ratio, but you don't understand how to do the division, or you've made mistakes with your division, please have more practice with your division. There were quite nasty questions in there, but you do need to know how to use long division, okay? Even if you're writing out your multiples down the side, whichever way you do it, you need to know how to do those. Okay? So let's look at this next example then. So Molly makes a blackcurrant drink by mixing 30 millilitres of blackcurrant with 450 millilitres of water. Hope makes a blackcurrant drink by mixing 40 millilitres of blackcurrant with 540 millilitres of water. Whose drink is stronger? And explain your answer. Okay, so what we need to do here is create 2 ratios for each person and then simplify our ratios to a unit ratio. And the reason that we do that is because then we have one comparable figure, because one of our constant elements of the ratio, so in this case it'll be blackcurrant or water, one of them will be 1. Okay, so they'll be the same. So then we can compare using the other number, okay, which one's higher or lower. That'll make more sense as we do it, okay? So we'll start with Molly. And it says she makes a blackcurrant drink by mixing blackcurrant, so B, to water with 30 ml blackcurrant to 450 millilitres of water. And the other person, Hope, mixes blackcurrant to water in the ratio 40 ml to 540 ml of water. Okay, so as you can see, they're not directly comparable at the moment because they don't put the same of anything in. Okay, Molly's got 30 millilitres of blackcurrant, Hope's got 40. But Molly's got less water and Hope's got more water. So you couldn't say, oh, Hope's is stronger because she's put more blackcurrant. Well, no, because she's put more water. So we need to get it to a unit ratio first so that you can check and be accurate. Okay? So I'm going to make my blackcurrant the thing that is constant, and then whoever puts the most water is going to be the one that has a weaker juice. Okay? So if we get our blackcurrant to 1, I need to divide by 30 here, and therefore I need to divide 450 by 30. Okay, 30 divided by 30 is 1. There's my unit ratio. 450 divided by 30 is, well, I know 45 divided by 3 is 15, so I know 450 divided by 30 is 15. Okay, so it's 1 to 15. Molly's ratio for blackcurrant to water. 1 part blackcurrant, 15 parts water. Hope's, we need to divide by 40 because it's the blackcurrant I want constant. I want that as 1 so I can compare the water amounts. So I need to divide the 540 by 40. 40 divided by 40 is 1. 540 divided by 40 doesn't go exactly, so I'm going to have to use my bus stop for my division. Oh, excuse that wonky line. 540 divided by 40. Okay. So 40 goes into 540 13 times, and that gets us to 520. So we have 20 remaining, that becomes 200. Okay, I know 4 goes into 25 times, so 40 goes into 205 times, and my answer there is 13.5. Okay, so it's 13.5 of water. Now you need to compare whose is stronger. Well, it's going to be whoever's got the lesser amount of water, okay? Because if they've got the same amount of blackcurrant and one's putting less water in than the other, theirs is going to be stronger. So Hope's drink is stronger. And you can put as she uses less water. Okay, or as I've said there, Hope's drink is stronger because it uses less water for every milliliter of blackcurrant. Okay, yeah, because that's in milliliters. So every 1 milliliter of blackcurrant, she's putting 13.5 milliliters of water, and for Molly, it's 1 milliliter to 15 milliliters of water. Okay, so hopefully that made sense as more of a comparison, and it shows you why we use unit ratio, because then one thing is constant and we can compare the other variable. Okay. Okay, pause the video then please and have a go at the 2 questions that are on the screen. I'll leave this example there so that you can refer to it if you need it, but play when you're ready to go through the solutions. Okay, so let's have a look. Question 15. Anna makes orange squash by mixing 50 milliliters of squash with 850 milliliters of water. Okay, so Anna, she uses squash to water and she does 50 milliliters to 850 milliliters. Jeevan makes orange squash by mixing 60 milliliters of squash with 1,110 milliliters of water. Okay, so let's write his out. So he mixes squash to water, 60 milliliters to 1,110 milliliters. Okay, who has the strongest squash? Explain your answer. So we need to put them into unit ratios, and I'm going to do that by making the squash the one that is going to be simplified down to 1. So to get 50 to 1, I divide by 50. That gives me my 1. And then I do 850 divided by 50 in order to find out my ratio of water, and 850 divided by 50 is 17. Okay, so that's my unit ratio for Anna. I need to do the same for Jeevan, okay? So I'm going to get the squash, it has to be the same thing that's been simplified to 1. So I'm going to get the squash to 1 by dividing by 60. I have to do the same thing to my water here. Oh, I've put the wrong number there though. I'm divided by 60, aren't I? I have to do the same thing there in order to keep my ratio equivalent. Okay, so it doesn't go exactly. So I'm going to have to use the bus stop method. I'm going to divide them both by 10. So I'm actually just doing 111 divided by 6 here. Okay, because it's going to give me the same answer, but it's easier to work with. Okay, 6 doesn't go into 1, so I carry that 1. 6 goes into 11 once, with 5 remaining. 6 goes into 51 8 times, with 3 remaining. We've got to the end of the number, so we need to put a decimal, and it had 3 remaining. That becomes 30. 6 goes into 35 times, so it's 18.5 there. Okay, and it says, whose squash is stronger? Explain your answer. Well, for every milliliter of squash, Anna puts 17 milliliters of water. And for every milliliter of squash, Jeevan puts 18.5 millilitres of water. Whose is stronger? Well, it's going to be Anna's. So Anna's squash is stronger as she uses less water to each milliliter of squash. So hers is stronger. Okay? And that's the end of that answer. So it's just getting them down to a unit form. Hopefully that one wasn't too bad. Next, question 16. Josh makes purple paint by mixing 2 litres of red paint and 500 millilitres of blue paint. Start by writing out Josh. Now there's an extra bit to this question that I hope you spotted. So Josh makes purple paint by mixing 2 litres of red paint. So we've got red to 500 millilitres of blue paint. Okay. 2 litres to 500 millilitres. We have to have them using the same unit. Okay, so we need to convert our litres to millilitres. So our 500 millilitres is okay. We need to convert 2 litres to millilitres, and that's 2,000 millilitres. So that was important there. Write the ratio out for Dexter now. So do Dexter over here. And Dexter uses a ratio of red to blue, and it is 1.5 litres of red to 400 millilitres of blue. Again, the 400 millilitres is okay, but we need to convert the 1.5 litres to millilitres, and that would be 1500 millilitres. Fantastic if you got that, okay? If not, you won't get to the right answer in the end, but well done if you've used the right method that we're going to continue using, okay? So I need to simplify, and I do that. I need to simplify to a unit ratio, and I'm going to do that by I'm going to compare the blue. The blue's a smaller amount, so I'm going to make the blue the constant by dividing by 500 and making that the one in both cases. Okay, so divide by 500, that becomes 1 milliliter, and then we need to divide 2,000 by 500, and there's 4 500s in 2,000, so that would be 4 milliliters. Okay, so that's 4 to 1 is my ratio there. I don't need the milliliters in there. Okay, 4 to 1. I need to do the same now for Dexter, and remember, as I've made the blue paint the unit ratio here, I need to do the same for Dexter, otherwise it's not going to be comparable. So I need to be dividing both of my numbers by 400. Okay, 400 doesn't go exactly into 1500, so I'm going to have to use my bus stop method. So I'm doing 1500 divided by 400. I'm going to take off the zeros. They're both divisible by 100, so I've simplified that and made it much easier for myself, because now I'm just doing 15 divided by 4. 4 goes into 15 3 times. I've got to the end of the number, so I need to put my decimal in. I'm going to just move that along because I've done the 2's. And that was with 3 remaining. Okay, that becomes 30. 4 goes into 30 7 times. With 2 remaining, that becomes 20. 4 goes into 20 5 times. So my answer is 3.75. So that's 3.75 millilitres to 1 milliliter. Okay, so it's 3.75 to 1. And the question says, whose paint is darker? Explain your answer. So whose paint is darker? The hint said darker purple paint has a higher concentration of blue paint. Okay? So there's a higher concentration of blue paint, therefore Dexter's is higher because he uses less red. Okay, so Dexter's paint is darker as he uses less red paint in his mixture. Okay, and that's the end of your answer there. Fantastic if you got that. That was trickier because you had to convert your units. They didn't give you that hint, and neither did I, because I just wanted to see if you could remember to spot it, as we have done that. But if you didn't, please do pause and have a go back through and see if you can get to the correct answer now. Okay. Question 17 and 18. For question 17, you can use a calculator, okay? There's an image of a calculator there because you can use a calculator. So please pause the video and play when you're ready to go through the solutions. Okay, so 17. It says, Raj makes concrete using aggregate to cement in the ratio 1930 to 265. So I have Raj, and he makes concrete using aggregate to A to cement to C in the ratio 1930 to 265. Sunil makes concrete using aggregate to cement in the ratio 935 to 175. Whose concrete has the higher proportion of cement? So whose has the higher proportion of cement? So this one is going to be Sunil, and his ratio of aggregate to cement is 935 to 175. Okay, now careful here. Whose concrete has the higher proportion of cement means that we don't want the cement to be the unit ratio. Okay, we don't want the cement to be 1. We want the aggregate to be 1 because we're comparing the cement. That means I need to divide both sides for Raj by 1930. Remember, you had a calculator, so this would be 1 because it's divided by itself, and 265 divided by 1930 would be 0.1373057. So let's round that to 2 decimal places, 0.14, because the 7 will round the 3 up to 4. Okay? So that's Raj. Now Sunil, we're going to make the aggregate the part of the unit because it's the one we're not comparing. So divide by 935 on both sides. This will give us 1 to 175 divided by 935, which is 0.1871658. Round that to 0.19 as we've done 2 decimal places. Okay, the 7 would round the 8 up to 9. So whose concrete has the high proportion of cement? Sunil's. So therefore, those 3 dots mean therefore, Sunil has the higher proportion of cement. Okay, and that's because to every 1 part aggregate, he uses 0.19 parts cement, whereas Raj, for every 1 part aggregate, he only uses 0.14 parts cement. Okay, so that's how you got your answer there. Question 18. Billy makes mortar by mixing 360 kilograms of cement with 90 kilograms of sand. So we have Billy, and he makes mortar by mixing cement with sand, cement to sand, by mixing 360 grams, or kilograms rather, of cement to 90 kilograms of sand. So that's Billy. Sam makes mortar by mixing 340 kilograms of cement with 85 kilograms of sand. Okay, so I've just started by writing out my ratios that were given and stating who each of them belong to, so it's nice and clear. So that's Billy's, that's Sam's. Then it said, whose mortar has the higher proportion of cement? Okay, so that means I'm going to get the sand to be my 1, okay? Because I'm not comparing my sand, so they can both be 1 because I'm not comparing the numbers. Then I can compare the cement that's with them, okay? So to get this to a unit ratio with the second part, the sand being the 1, I'm going to divide by 90. So I need to divide my 360 by 90, and that would give me 4. So Billy uses a ratio of 4 to 1. And then we need to do the same with Sam. Divide by 85. Divide by 85. That's 1. 340 divided by 85 is 4. So whose mortar has the highest proportion of cement? They have the same. The same proportion of cement. Okay? And that's the end of your answer. Fantastic if you got those, well done. I think the hardest part in those questions, the biggest difference was picking which one you make your 1 and which one is the one that you're comparing. But hopefully you can see how you do that now. Okay, you've got an exam style question now. I'll quickly read through it with you, read your exam hint, and then you can pause and play the video when you're ready for your solution. So the question says, electrum is 2/5 gold and 3/5 silver. Jessica says the amount of silver in one is the amount of silver in 1.5 times the amount of gold. Okay, so the amount of silver is 1.5 times the amount of gold. Is she correct, and explain your answer? Okay, your hint says explain your workings and answer by writing your reasons alongside your calculations rather than listing them at the end. Okay, so as you go, explain your answer. Okay? So let's have a look. So electrum is 2/5 gold and 3/5 silver. So we've got gold to silver, 3/5 to 2/5. Okay? I want to get rid of my fraction because I don't write ratios in fractions, and I know that actually that will just be 3 to 2. Okay, we know that from our previous lessons, so 3 to 2. Jessica says the amount of silver is 1.5 times the amount of gold. Okay, so the amount of silver, I've written those the wrong way round, haven't I? Apologies, let's just start that bit again because I've written them the wrong way round. So we had gold to silver, and it was 2/5 gold, no, not 3/5, 2/5 to 3/5. I'm sorry about that if you got confused when I was just going through that solution. So my ratio is 2 to 3. And Jessica says the amount of silver is 1.5 times the amount of gold. So what you're asking yourself is 1.5 times of 2. So you need to do 2 multiplied by 1.5 and work out what that equals. Okay, and it is non-calculator. So I know 2 times 1 is 2, and I know 2 lots of 1/2, 2 lots of 0.5 is 1. 2 plus 1 is 3. Therefore, yes, she's right. The amount of silver is 1.5 times the amount of gold. Okay, so yes. They've put in the answer, gold to silver is 2 to 3. And then you can say 2 times 1.5 is equal to 3. Okay, therefore it means that Jessica is correct. Okay. Well done, that's the end of the lesson, the end of the unit 11.5. Next time we'll be moving on to 11.6.